Hi everyone. So what we're going to work on today is finding out what this decimal is down at the bottom of the periodic table. So beforehand we were working with the mass number, right? Mass number is the amount of, it's the mass of a single atom. So just one atom of oxygen, one atom of nitrogen. Okay, so but that's not feasible. When we're dealing with that stuff, we can't just say one atom because you got to remember that 6.2, excuse me, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. I don't know what I just did there. Sorry. Molecules of water in 18 of H2O. I'll just do that. H2O is in 18 grams of pure water. Okay, so we can't, we logistically and professionally can't just and statistically and logistically we can't look at one single atom. So we have to look at the group of atoms. Okay, and so because there's, I don't know how much water on Earth, just a tremendous amount. Okay, so when we do this, we can't look at one solitary atom. So remember, the mass is the amount of protons and neutrons, but we need to look at the general trend of sample sets of a substance. Okay. All right. So I'm going to give an example right here. This is PHET, P-H-E-T, and this is talking about the evolution of rabbits. Okay. It is similar but not, because we're going to be talking about, let's say that this is recessive, and we're going to add a mate. Okay, so we have two bunnies. Boop, 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 boop. It's going to take a little while. And I'm not putting any regulations like wolves in there, tough food, limited food. We're just looking at the population growth. So two bunnies made, I think, what, 6, 7 bunnies? And then 6, 7 bunnies made, oh, what, 15? I'm just taking guesstimations. Oh, it jumped really and it went over to 60. That's the third population. But look, I'm going to pause it if I can get there. Something occurred and we start getting some brown bunnies. Okay, so if I were to pick a bunny out of here, most likely it would be a white bunny, but once in a while we'll get a brown bunny. Oh, tremendous more amount of bunnies. So most likely there's a few brown bunnies if you look in here. I think this is the last generation that they'll show. But if I were to pick a bunny, it would be a white bunny. But there is a chance to have a brown bunny, though a very slim chance. Uh-oh, the bunny's taken over the world. So, what does this have to do with what we're learning? It's all about the proportion. So, beforehand, I had done it and it was 83%. It was by chance. It's not necessarily the way in the atomic world, but for right now, this is what we have. So, out of 1429 bunnies, 2% of them are brown right here. But that throws off the population just a tiny bit. The most likelihood your sixth, your seventh, your eighth generations are going to be white. I am not really talking about generations because that's kind of not what atoms do. There's some degradation within the nucleus, which we won't get into, that creates these different amount of atomic structure. So if you look here, there are 1400. Remember, just in 18 grams of water, there's this many molecules of hydrogen or of water, excuse me, when you're looking at a sample set of pure water. So this is, we're going to be talking about the average and atomic, basically the average atomic mass. So basically what it is the amount of a stable isotope. Oop, it read my mind. Of a stable isotope. Um, Okay, so it's the amount of each type of stable isotope in a given substance. So each substance, each element's going to have a different variety. If it's not stable, then it's actually going to degrade into another element. And that's for later on. Probably if you guys go on to college, you'll learn the nuclear chemistry behind that. Okay, so for example, carbon has actually kind of three stable isotopes. And I've done this before, and they are carbon 12, carbon 13, and carbon 14. Okay. All right. So each of those weights, when I get a sample set of just a big chunk of coal, they're going to have each of these, but they're going to vary in different sizes. So if I look here and I see carbon is 12.011, that is going to say, hey, the majority of it's going to be carbon 12, but we're going to have some more of those. Okay, so it's just going to vary for the given substance. But what somebody does and what we'll learn is that somebody gets paid a lot of money to figure this out. Now, in real life, are you going to have to find that out? No. But what we're teaching you is tools where you can use proportions and figure out the given amount of each substance, which you may or may not use in real life, but it's providing you tools to problem solve and find those math relations. Okay, so I'm going to go ahead and I'm going to do an example. Everybody, we've done this before. So what